Alright guys, welcome to this video. In this video we are starting chapter 4, which is integration. Okay, so another name of integration is antiderivative, so which is just the opposite of the derivative. For example, do you remember that what is the notation for the derivative? There were several notations for the derivative, but one of the notation was d over dx, right? So d over dx of x to the cubed is how much? Do you remember that? Just use the power rule, n and then x and minus 1, that is 3x squared. We did that way, right? So basically the notation for the derivative here is d over dx. So for the antiderivative, we use a notation like this is the integral sign, and then that comes with dx. Okay, the function will come here in the middle. So this is like integral sign, or the antiderivative sign is like s type of thing, and then there is a dx that comes at the end. All right guys, so let's see some examples. So the derivative of x squared, it is like d over dx x squared is derivative of x squared, because this is the notation for derivative, d over dx. You cannot cancel d and d. So that's the notation for the derivative of x squared is 2x. So what can we say is the antiderivative of 2x must be x squared. It's just the opposite, okay? The antiderivative is the opposite. So the integration of 2x or antiderivative of the 2x, you see that? We wrote s symbol and then dx here, right? So integral of that thing is x squared. But you see that why I wrote x squared plus c? I will discuss about that. Look at this. The derivative of x squared is 2x, right? Similarly, what is the derivative of x squared plus 5? So it is also 2x, right? So the antiderivative of 2x can be just x squared, or x squared plus 5, or x squared minus 1, because the derivative of x squared minus 1 is also 2x, right? So what is the antiderivative of 2x then? Antiderivative of 2x can be x squared, or x squared plus 5, or x squared minus 1, or x squared plus or minus any number, right? That's why we wrote the antiderivative of 2x dx is x squared plus a number c. That c can be 0 or 1, 2, 3 or negative 1, 2, 3, anything there, or just a number. That's why we write that. Now what I did both sides is I divided by 2 on both sides. What we get is antiderivative of x dx is x squared plus 2 plus another constant. So this was c, I assume that as c. So I assume that as c prime because I divided both sides by 2, right? I did like 2 and then 2 and then 2. So I denoted the new constant by c prime. But you can just write c, that c is different from that c. You can take that way. But this is how we got the antiderivative of x dx is x squared over 2 plus a constant c prime. Similarly, what is the antiderivative of, what is the derivative of x cubed? The derivative of x cubed is 3x, 3 minus 1, that is 3x squared, right? So what we can say there is the antiderivative of 3x squared will be x cubed plus c. The antiderivative of this must be that one, right? So what we can say from here is basically, if you divide both sides by 3, you will get the antiderivative of x squared, or the integral of x squared dx equals to, I divided both sides by 3, x cubed over 3 plus c. You remember that how I got c? Because the derivative of x cubed is 3x squared. Derivative of, if you say x cubed minus 1 is also 3x squared. If you find the derivative of x cubed plus 10, this is also 3x squared, right? All of them have the same derivative, right? That's why the antiderivative of 3x squared could be x cubed, or x cubed minus 1, or x cubed plus 10. That is the reason why I wrote c as we discussed for x squared, right? So the antiderivative of x cubed dx, x squared dx is x cubed over 3 plus c. Now from this, can you guess? So look at this one. If the exponent is 1, then the antiderivative will be exponent plus 1, that is 2, divided by what exponent you got here, that will go in the denominator. You see that? Similarly here, when the exponent is 2, the antiderivative of x squared is x cubed over 3. You can think like the whatever exponent there plus 1 over that thing plus 1, right? The exponent plus 1. So basically, it's like a power rule, but it increases the power. In the derivative, it decreases the exponent, right? But here it increases in the antiderivative, because that is the opposite of the derivative. Okay, so you see, for the derivative, that power goes to the first, and then you write x and then 1 less, right? But here, you increase the power by 1 and divide by that power. We don't multiply, we divide by that power. So can you tell me what is the antiderivative of x cubed? So you see that the antiderivative of x cubed is, you should write x to the 3 plus 1, the power plus 1 over 3 plus 1 and then plus c. This plus a constant is default in the antiderivative because you always write that for any antiderivative problem, you write plus c, okay? But here it is x to the third, means x to the third plus 1, the antiderivative over 3 plus 1. That is, what you get is basically x to the 4 over 4 plus 1. That's what you get. How about x to the fourth? Antiderivative of x to the fourth. Can you tell me the final answer? Yes, you're right. X to the 5 over 5 plus 1. So who can tell me what is the antiderivative of 1? There is no x to the exponent, right? So you can write 1 as x to the 0, right? Anything to the 0 except 0. Any number to the 0 or any variable to the 0 is 1. So you can write that way. So you use the same formula. 0 plus 1, x to the 0 plus 1 over 0 plus 1 plus c, right? So what do you get? X to the 0 plus 1 is just x to the 1, is just x over 1 is just x, right? So you get x plus c. You remember, you can see the other way. You can check your answer, okay? How do I check my answer then? To check whether the antiderivative of x cubed is x to the 4 over 4 plus c, not 1, plus c is a right answer or not, what you do is find the derivative of this. You must get that function, okay? What is the derivative of x to the 4 over 4? You don't have to use quotient rule here. Just pull the 1/4 out. And the derivative of 4 will be, x to the 4th will be 4x to the 4 minus 1. 4x cubed. And you cancel 4 and 4. Basically, you get x cubed. And the derivative of constant is 0. C is 0. Similarly here, the derivative of this is 5x to the 4th divided by 5. That is 5 and 5 will cancel out. So x to the 4th, this is also c. And so x to the 4th plus the derivative of c is 0 here. So what do you get? X plus c, right? What is the derivative of x plus c? Derivative of x is 1, derivative of c is 0. So just 1. That's how you can check. So these are some of the formula that we get. So can you tell me what is the derivative of 0? You can think this way. What is the function whose derivative is 0? A number, right? A number has derivative 0. That's why integral of 0 is a number. Let's say c. So integral of 0 is c. The derivative of c is 0. It's just the opposite. So can you guess what is the integral of k? You can write like this. You can pull that k out and then do 1 dx. But what is the integral of 1? It's x plus c, right? So you can do k and then x plus c, right? Basically, you can simplify this as k times x is kx plus k times c. K is a constant, c is a constant, so you get another constant, let's say c prime. So basically, the integral of k, integral of a constant is constant times x plus a constant. You can write c or c prime. So we just did for the next formula, we did that, right? So if there is any exponent n in the integral, when n is not equals to 1, n cannot be equals to -1. If n is -1, then n goes to the denominator, right? And then that will get a problem here. So suppose n is not equals to -1. Okay, we will see other things why n cannot be equals to -1. So what is the antiderivative of that? It is x to the n plus 1 over n plus 1 plus c. You see that? We got that everything here. X to the 1 has x squared over 2. X to the 2 has x cubed over 3. And then x to the 3 has x4 over 4. X to the 4 has x5 over 4. x5 over 5 and so on. That's why x to the n, where n is not equals to -1. Okay, it cannot be equals to -1. Why? If n is -1, then you will get -1 plus 1 is 0 there, right? So which gives you infinity. That's why n cannot be equals to -1. So what is the antiderivative of cosine x? Tell me, whose derivative is cosine x? We know that derivative of sine x is cosine x, right? So what is the antiderivative of cosine? Antiderivative of cosine must be sine, right? So similarly, what is the derivative of cosine x? Cosine of x derivative is sine x, right? Negative sine x. So the antiderivative of sine x will be negative cosine x, like that. So it will be, the antiderivative of cosine x will be sine x plus c. You see that? Because the derivative of sine will be cosine and derivative of c is 0. Similarly, this will be negative cosine of x plus c. Why? Because the derivative of negative cosine is positive sine. So who remembers what is the derivative of, which derivative is secant squared? You're right, the derivative of tangent x plus c is secant squared. How about secant tangent? Derivative of secant x plus c is secant tangent. That's why the antiderivative of secant squared is tangent. Antiderivative, oh, I forgot dx here. I need to write that dx here. So antiderivative of secant x tangent x is just secant x. Which derivative is cosecant square x? That is negative cotangent x plus c. So the derivative of negative cotangent is positive cosecant square. That's why the integral of cosecant square x is negative cotangent x plus c. Similarly, this is negative cosecant x plus c, and these two are just for the general function. If there is sum in the integral, you can distribute that integral. See, there is fx plus gx inside the bracket there. What I did is I assigned the integral and then dx to fx, and the integral plus in the middle. You see that? That is the plus. We had the plus here. And then integral of gx, dx. Integral and the antiderivative are the same thing, okay? Now the last one is, if there is k or constant number times a function, then you can pull that out and then find the integral of constant only. So these are the formula, that the basic formula that we will be using in the examples. Let's see the example here. Let's do this example. You have integral of 4x squared plus root x dx. Let me write this as simplified form. Since this is a constant, okay, so you can pull that out. That's what this says, right? If there is a constant multiplying to a function, you can pull that out and then find the integral of that. So you can write 4 and then integral of x squared dx plus, you can distribute. Since there is a plus, you can distribute this. If there is a product, you cannot distribute. You cannot do integral of 4 times integral of x squared, but you can do for plus and minus. If there is minus as well, you can do plus and minus there, okay? So here you can do integral of, what is root x? Root x is x to the 1/2 dx, right? If you simplify this, if you use the formula here, what do you get? 4 times, what is x squared? Integral of x squared, it is x cubed over 3, right? Plus c, plus, what is the integral of that x to the 1/2? It is x to the 1/2 plus 1 over 1/2 plus 1 plus another c, right? Another constant c. So what you write here is, you can say this is c1 and then this is c2. This is the first constant you got from here and second constant you get from here, right? So what do you do with that is simplify. You got 4/3 x cubed, right? Because 4 over 4 times x cubed, 4x cubed over 3, or 4/3 x cubed. I will combine c1 and c2 and then I will write plus c at the end. So you don't have to write c in every term. What you do, you'll write a plus c at the end. Okay, plus, what is x to the 1/2 plus 1? Is x to the 3/2 over 1/2 plus 1 is 3/2, right? And then plus or c, because I added c1 and c2 and I wrote plus c there. So if you simplify this, what you get is 4/3 x cubed, right? And then plus, I want to write this in nicer form because it is like this function, this term divided by a fraction. So what you can write is, you can write 2/3 and then x to the 3/2 plus c. So this is the final answer. How do I get that 2/3 here? Because it is like, if there is a over b divided by c over d, how do you do that? You write the top fraction. times, you'd write the reciprocal of the bottom fraction, you do d over c. So basically you'll get AD over BC, that's what you get. So I use that formula. So let me erase these terms to write the second example, okay? Okay, how do I do the second example? Because all these formula needs the function to be on the top, not on the denominator, right? Everything here, it is written in the top. The bottom is just 1, right? Like secant square x over 1, sin x over 1, that's why. So if there is something on the bottom, you should move that to the top. So how do you do that? Since 1/4 is a constant, you can pull that out. 1/4, and what is left is x to the negative 2 dx. You understand that? I move this x squared to the top, but 4 I pull that to the front. So what is the formula? X to the n has x to the n plus 1. So there is 1/4 already. X to the n plus 1, negative 2 plus 1 over negative 2 plus 1 plus c, right? If you simplify this, what do you get? You get 1/4 x to the negative 1 over negative 1 plus c. And if you simplify this, you will get negative 1, 4 times negative 1 is negative 1/4 times, and then this x to the negative 1 goes to the bottom with making x to the positive 1, right? So 1 over 4x plus c is the final answer. Number 1. How about example number 3? There are two terms, but they have the same base. X to the 1, what is this? What exponent of x is root x? X to the 1/2, right? So you can write integral of 1 over x times x to the 1/2, right? dx. So how do you do that? It's 1 over x to the 3/2 dx, right? So you can move this to the top because there is no formula that we can apply that has x in the bottom, right? So you need to move that to the top and use that formula. You will get integral of x to the negative 3/2 dx. Now use that power rule formula. X to the negative 3/2 plus 1 over negative 3/2 plus 1 plus c, right? After you use the formula of the integral, then you write plus c. So what is that? X to the negative 3/2 plus 1 is how much? X to the negative 1/2, right? You can use calculator. Or it is negative 3/2. Is there a 3 3/2? A 3 negative 3/2 and then plus 1 is the 2/2, right? So you can subtract that way. So it is negative 1/2 plus c. If you simplify, what do you get? This 2 goes to the top and the negative. So negative 2 and this goes to the bottom over root x. You see that? Plus c. This is just the simple algebra trick. You know how to do that. Alright. How about example number 4? How do I do this? For this problem, you do integral of 13 dx minus integral of x dx, right? So do you remember how do I find the integral of a constant? Integral of a constant has, where is that? Integral of a constant, formula number 2, right? It is kx plus c, kx plus constant. So here k is like a 13, so it will be 13x. So I will write the constant at the end, okay? Because I'll get one constant from here and another constant from here. So I will combine those two constants and write a single constant as c, okay? So this will be 13x minus, what is the integral of x? Integral of x will be x squared over 2, right? Because see, so integral of x is x squared over 2 plus c. Or you can see that this is x to the 1, right? So x to the 1 plus 1 is x squared over 2. And then plus a constant you will get from here, another constant you get from here. I write a single constant by combining those two constants. That's the answer. Okay. How about here? We have the 3 terms, right? You find the integral separately. So how would I write this? Is I would write x to the 3/2 and then plus I would write, oh, dx. I should not forget dx. 2 and then integral of x dx plus integral of 1 dx, right? That's how you write. And then use the formula. What is that? X to the 3/2 plus 1 over 3/2 plus 1, right? Plus 2 times x to the 1 plus 1, right? X, because there is x to the 1. So x to the 1 plus 1 is x squared over 2 plus c, but I'll write that the whole c at the end. So plus The integral of 1 is x, because the derivative of x is 1, that's why integral of 1 is x. And I write plus c at the end. That c is the combination of all the constants you get from each term. So what do you get? You get x to the 5/2 on the top, but in the denominator you will get 5/2. If you want to write in the nice form, you write 2/5 on the top, right? This cancel out, so plus x squared plus x plus c. This. How about here on example 6? See, there is x in the top, x in the bottom. How do I simplify this? Because I don't want x in the denominator, because none of these formula have x in the denominator, right? So what I do here is I split the denominator, x over root x plus 6 over root x and then dx, right? Now, how much is that? You can just split the, distribute the integral, or you can distribute later, but let's simplify first. How much is this? This is x to the 1/2, right? You move this to the top, you will get x times x to the negative 1/2, right? And then plus 6 times x to the negative 1/2, and then there is dx. See that? If you simplify, you will get x to the 1, and then minus 1/2 will be x to the 1/2 plus 6x to the negative 1/2 dx. You see that? Now I distribute the integral, x to the 1/2 dx plus 6 integral x to the negative 1/2 dx, right? So what is the integral of this? Is x to the 1/2 plus 1. I'm using the formula number 3 again. So you get x to the 1/2 plus 1 over 1/2 plus 1 plus 6 x to the negative 1/2 plus 1, right? Whatever exponent you have, when you find the integral, you add 1, okay? Negative 1/2 plus 1, and then plus c, right? So let's simplify that. You get x to the 3/2, because 1/2 plus 1 is 3/2. You will get 3/2 on the bottom, but I will write 2/3 on the top, okay? Plus, what do you get here? There is 6, and you will get 1/2 here, right? Positive 1/2, because negative 1/2 plus 1 is positive 1/2. But when you write in the top, you'll get 6 times 2 is 6 times 2x to the positive 1/2 plus c. So the final answer look like this: 2/3 x to the 3/2 plus 12 x to the 1/2 plus c. This is the final answer. Okay, guys? So here, just one more time, what we do is you will get negative 1/2 plus 1 is positive 1/2, but then 1/2 is in the denominator, right? If you want to write in the numerator, it will be like just 2. 6 times the reciprocal of 1/2 will be 2 over 1. That's why I got 2. Okay, that's why. Next, we'll do example number 7. Let's do example 7. So here there are two functions. One is the cosine x, another is the sine x function. So I will distribute the integral sign. I'll write 5 cosine of x dx plus 4 sine x, integral sine x dx, right? So what is the integral of cosine x? It is like 5. It is sine x, because the integral of cosine x is sine x, right? This one. And another integral is of sine x is cosine x. So 4 negative 4 cosine of x plus c. You see that? Integral of cosine of x is positive sine x, but integral of sine x is negative cosine x. So I multiply that negative with 4, so negative 4 cosine x. That's what you get. Alright, guys? Let's do example 8. So this is equals to, because you cannot distribute that integral over the product. You cannot write integral of secant y and then times integral of tangent minus secant. That product will have a product rule like we call integration by parts later. But for now, what we do, you simplify. You get secant y tangent y minus secant squared y, right? If you distribute that secant y, multiply it to both tangent y minus secant y, you will get that dy. Now what I do is I distribute this to both of these. So integral of secant y tangent y, and then my dy, and then minus integral of secant squared y dy. Can you tell me what is the integral of secant y tangent y? Where we have that? Maybe I forgot to write that one, right? Oh, there is. So number 7, secant x tangent x has secant x plus c, because the derivative of secant is secant times tangent. So it is like secant y minus, what is the integral of secant square? Meaning, what function has the derivative secant square? That is that one, right? Number 6. So secant square x dx is tangent x plus c. So it will be tangent y plus constant. You will get one constant from here, another from here, but I combined those two and I wrote a big c. That is plus c. So that's the final answer for this. Okay, guys? Thank you.